Now here's the last one. This one's a tricky one. So we'll first probably want to determine our endpoints, or our like critical points where our inequality could plausibly flip. So that'd be like here at like, that would be at x equals 1 when this thing is at 0, when this thing flips signs. And similarly at x equals -1 when this thing is 0. And we also will have fancy stuff happen, because what if we cross multiply? This becomes x squared minus 1 is something to 9, we don't know. But I'm just gonna like, when we're at equality case, x squared minus 1 equals 8, which means x equals plus or minus 3. So those are our important points on this range that we'll want to check. So now we separate it into some cases. So case 1. What if x is greater than 1? If x is greater than 1, that means that x plus 1 is, we already know this. And since x is greater than 1, that means that this is positive, which means that it is in fact legal for us to multiply by x minus 1. So this becomes x plus 1 times x minus 1 is greater than 8. X squared is greater than 9. And since x is positive as well, this means that x is greater than 3. So the only parts of this, the only parts of x greater than 1 that are legal is x is greater than 3. Now we move on to case 2. X is less than 1. In which case we once again have x plus 1 is greater than 8 over x minus 1, but this time this is negative. So that means that if we multiply by x minus 1, we'll have to flip the sign. So let me give an example. For example, let's say we originally have 4 is greater than 2. If we want to multiply both sides by -1, we'll have to flip the sign now, because now we used to have 4 is greater than 2, but -4 is not greater than -2. -4 is less than -2. So since x minus 1 is negative, we have to flip the sign. So we now have this x squared minus 1 is less than 8, or x squared is less than 9. Since x is less than 1, we must have that x is less than -3. And oops, no, we must have that x is greater than -3. Kind of trippy. Or alternatively, we were just taking on this side, we're taking this set and we're taking the union with the set of x squared is less than 9, which is this, which means that the ones that we actually end up getting are these two. These are the ones that we actually end up getting. So here are our two valid ranges. For x is greater than 1, 3 to 5. That's our only valid range. If x is less than 1, our only valid range is from -3 to 1. And so over this entire interval, we have that there's 6, 1 minus 3, 1 plus 3 plus 5 minus 3 over 10. That's the total size of our interval, which becomes out to 6 over 10, which equals 60%. So 60% of the interval consists of real numbers satisfying the inequality. Tricky problem. When x is less than 1, you're not allowed to just multiply.